Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. We've got terms instead of steps today, term 1, term 2, term 3, and term 4. And your challenge is to predict the number of squares in term 5. If you can do that, can you predict the number in term 43? And can you write an equation to express the number of squares in any term at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. So this is an odd shaped pattern. I guess what I'm noticing is that there's this kind of backwards L shape on each of these steps. I guess it's here too, and that keeps growing. And then there's a square that keeps growing to the right of that. So let's see, this is a 1 by 1 square, 2 by 2 square, 3 by 3 square, 4 by 4 square. So I would guess there'd be a 5 by 5 square here, so that'd be 25 squares. And then this L, let's see, first it's 2 long on the bottom, then 3, then 4, then 5. So this would be 6 long on the bottom. And then of course it's 1 less than that on the top, so 5 here. So that'd be 25 plus 11. Looks like 36 for term 5. Does that look right to you? So interesting pattern. I'm sure we could express that algebraically, and you might jump to an equation right now with that. But I think we should analyze the numbers first, because that might actually make this one even simpler. So let's make a chart with the step number and the number of squares in each step. So in step 1, that's 4. And in step 2, let's see, 4 and 5, that's 9. And in step 3, there's 9, 10, 11, 12, 13, 14, 15, 16. And in step 4, looks like we've got a 4 by 4 square, 16. And it looks like that's 25. And in step 5, we're saying 36. And right away, this should jump out at you. All of these numbers are perfect squares. I mean, we could analyze them like we usually do, take the differences. That's a 5, that's 7, that's 9, that's 11, and then you take the difference of the differences and you get 2 and 2 and 2, which tells you this is a quadratic pattern. But that should be clear too, because we saw those squares growing from step to step. But this tells us, this without even taking the differences, we've got squares going on here. And it looks like, in step 1, this is 2 squared. In step 3, this is 3 squared. Sorry, in step 2, this is 3 squared. In step 3, this is 4 squared. So we're just taking one more than the step number and squaring it. So we would have x plus 1 quantity squared. And that should be our equation. And I'll show you that this works. Let's just do it with step 4 here. We would put 4 plus 1 and square it. 4 plus 1 is 5. You square that, you get 25. And that's how many there are in step 4. You can try that out with any of these terms that you like, and it should work out. Now, of course, you can FOIL out this thing, but I like it like this because this relates exactly to what we see in this chart of numbers. So I'm just going to leave it as y equals x plus 1 squared. Simple enough. Now, to calculate the number in step 43, we just put 43 in here. So that's going to be y equals 43 plus 1 squared. And that's 44 squared, which is 1,936. So that's how many squares I think there are in term 43 of this visual pattern. Do you agree? How did it come out for you? Did you see this pattern right away? Did you come at an equation from a different perspective? If you did, I'd love to know. Well, thanks everybody.